So this sensors, as I told, we discussed about the previous in the previous class about the different types of sensors depending upon their positional, right, and the functionality of the sensor types and the descriptions and the different examples we have studied. So next we are going to study about the sensors or the power of sensors, and they play a very important role in the IoT as an area of precision. In case of agriculture, sometimes they refer to as a smart farming. It uses variety of technical advances to improve the efficiency, sustainability, and profitability of the traditional farming practices. I told now. So that some motion sensor which is going to identify the object, movement of the object, right? So it sends a signal to the farmer stating that some object is moving in your land, right? So GPS and satellite aerial imagery for determining field viability, robots for high precision planting, harvesting, irrigation. So that is, say for example, you want to check the fertility of the soil or humidity of the soil, right? So these are all possible with the IoT sensors. We are going to uh, we are having a sensor there which are going to identify the humidity of the soil and the fertility of the soil, right? Whether that is a soil is we can able to do the irrigation, or we are going to you can use it for crop, right? Real time analytics and artificial intelligence to predict optimal crop yield, weather impacts, and soil quality, as I told that. See, so different biodegradable sensors are developed by NDSU for smart farming, right? See there, this is a company which is going to produce biodegradable sensors. Means they can dissolve in the soil. If you are going to insert inside the soil, also nothing will happen. So think that they are electronic devices, even though also they are biodegradable. Their manufacturing is which is going to use some material which is going to be dissolved in the soil. So this is a couple which has produced a lot of biodegradable sensors which are going to be inserted in the field, right? And they are going to send the signal to the farmer stating that the humidity of the soil maybe, that is a movement of the object in the field of the farmer, right? So once they are going to insert it, so deployment, the sensor deployment is mobile phones, smartphones with potentially hundreds of sensors, intelligent vehicles with 100 plus sensors each, connected cities with thousands upon thousands of connected sensors, as sensors available in cheaper rate, right? See now, our mobile device is going to connect it with the different sensor going to connect it to our smartphone. So near field communication, there will be a camera and proximity sensor, magnetometer, accelerometer, humidity sensor, gyroscope, moisture sensor, microphone, fingerprint sensor, digital barometric pressure sensor, touch screen, and you have the light sensor, GPS, that is a global positioning system, pedometer. All these are they connected the different sensor which are present in our the smartphone. See now how the increasing the use of the sensors in our daily use, growth and predictions in the number of sensors. Say 2007 it was only so this much, right? So in 2012 it has been increased, 2017 it has still increased, 2022 it is going to increase. Means so many sensors are going to be connected to our mobile phones or and different devices which we are going to use. Then come to the accutators. So next part of this one is the accutators. These accutators are natural complements of sensors. Accutators will receive some type of control signal. So when we are going to use those accutators in our devices, right? So these accutators play a very important role in IoT network, right? So these the accutators are something we call them as the natural complement to sensors we call, and the diagram which is shown in below, see there, okay, demonstrate the symmetry and complementary nature of those two types of devices. Say there, digital representation, electric signal, sensor sense and measures, and they are going to represent that in the digital form, light or electric signal, and they in turn to that digital representation, accutators going to act and perform the useful work and send it to the real world or the physical environment. You can see that, okay. Those two devices, as we have discussed in the previous sections, sensors was designed to sense and measure practically any measurable variable in the physical world. They convert their measurements, typically analog, into electric signal or digital representation that can be consumed by an intelligent agent, a device, or a human. Accutators, on the other hand, receive some type of control signal, commonly an electric signal or digital command, that triggers a physical effect, usually some type of motion, force, and so on. The previous section draws a parallel between the sensors and the human senses, that is a human organ, sense organs, right? These parallel can be extended to include the accutators as shown in the figure. See how sensors and accutators interact with physical world. The sensory organ convert the sensory information into the electrical impulses that the nervous system sends to the brain for processing. Likewise, the IoT sensors or devices that senses and measures the physical world and typically signal their measurement as electric signals sent to some type of microprocessor or microcontroller for additional processing. The human brain signals motor function and movement, and the nervous system carries that information to the appropriate part of the muscular system. Correspondingly, a processor can send an electric signal to an accutator that translates the signal into some type of moment, linear, rotational, and so on, or useful work that changes her as a measurable impact on the physical world. This interaction between sensors, accutators, and processor and similar functionality in biological systems is a basis for the various technical fields including robotics and biometrics. You can see here sense organs of a human being, say tongue, skin, eye, nose, then ear, right? And they read, they sense, then they send that signal, electric impulses in turn sent to the brain nervous system, then in turn that brain sends to different parts to act according to that, okay. So this part which you are going to act, they are called as the accutators, they are going to act, okay. Now sensors sense and send the signal to the CPU. In turn, with the CPU data, right, the accutators are going to act according to that. IoT sensors are devices that sense and measure the physical world and signal their measurement into some type of microprocessor or microcontroller, what we call it as a CPU here, for additional processing. The human brain signals motor function and movement, and the nervous system carries that information to the appropriate part of the muscular system. Correspondingly, a processor can send an electric signal to an accutator and translate that signal into some type of moment, linear, rotational, and so on, or useful work and changes or has a measurable impact on the physical world. This interaction between sensors, actuators, and processors and similar functionality in biological systems is a basis for various technical fields including robotics and biometrics. Okay, you can see there, much like a sensors, actuator also vary greatly in their function, size, design, and so on. Some common ways that they can be classified that depends on the type of the motion, okay, and the power, the binary or continuous, okay, then the area of application and type of the energy, and the most commonly used classification is based on the energy type. Before going to this energy type, we'll study one by one the classification of these actuators. The type of the motion when you come, actuators can be classified based on the type of the motion they produce. For example, linear motion, rotary motion, one directional, two directional, or three directional axis. Next is a power. Actuators can be classified based on their power output. For example, if you take a high power, low power, and micro power, okay, low energy, medium energy, and the high energy. Okay, so binary or continuous. The classification is also based on the binary or continuous. Actuators are classified based on the number of stable state outputs. It is a 0 and 1, we can say. Binary representation is what? 1 is representation as a on and 0 representation as a off, right? So stable or state outputs. So whether it is high, high is represented as 1 and it is low when it is represented as 0. When you come to the area of application, actuators can be classified based on the specific industry or vertical when they are used. Okay, so depend upon the what kind of industry we are going to use that sensors or the actuators, right? So when it comes to the type of energy, actuators can be classified based on their energy type. It's a very quite complex to given their variety. So this is no means in an that exhaustive list of classification schemes. The most commonly used classification is based on the energy type. So this table below table classified based on the energy type and some example for each type. Again, this is not a complete list, but it does provide a reasonably comprehensive overview and highlights of the diversity of the functions and the design of the actuators. Say for example, if you take actuators based on the energy type, so mechanical, the actuators which are going to use a mechanical energy, they're classified as a mechanical actuators. Example, we take lever, screw, jog, hand crank. Okay, so if it is based on the electrical energy, we call them as a electrical actuators. Example are thyristor, bipolar, transistor, diode. Okay, so combination of both electrical and mechanical energy, when it is combined, then those actuators called as electromechanical actuators, right? And example for this electromechanical energy actuators or AC motor, DC motor, step down or step up motors. Okay. So AC motor, it uses a current and motor is made up of a mechanical device. Again, direct current, DC is a direct current which is electrical energy and motor is again made up of mechanical devices, right? When it rotates, it produces mechanical energy, right? So we call that is a DC motor. Step up and step down transformers, motors which are used for conversion of AC voltage into DC voltage. Okay. Now the electromagnetic actuators, that are those are the kind of energy which they are going to combine both electrical energy as well as a magnetic energy. Okay, so those actuators we call it as electromagnetic actuators. Example, electromagnet, linear solenoid. Those are the devices. Next is the hydraulic and pneumatic actuators. That is when they are going to apply the hydraulic energy and pneumatic energy, we designate them as hydraulic and pneumatic actuators. The examples are hydraulic cylinder, pneumatic cylinder, piston, pressure control valves, and the air motors. They all come under the hydraulic and pneumatic actuators. Then smart material actuators, which are made up of thermal and magnetic actuators, right? So they are made up of thermal energy and magnetic energy. We call them as a smart material actuators. Their example is shape memory alloy, okay, ion exchange fluid, magneto-restrictive material, bimetallic stripe, piezoelectric biomorph. These are all comes under the smart material actuators. Other kind of actuators is micro and nano actuators. That is which are very minute actuators. They are going to act according to that. They are electrostatic motor, micro valve, and comb drive. So these are all the devices which are based on the energy type which we are used. That is a classification. So whereas sensors provide the information, actuator provide the action. As I told in the different diagram that so human sense organs and the how it is going to actuators are going to act. Okay. So it is correlation between the electronic devices and the human nervous system and the human sense organs. The most interesting use case of IoT are those where sensors and actuators work together in an intelligent, strategic and complementary fashion. Okay, both together, both sensors and actuators both together act in a smart way, right? So that they work together in an intelligent and complementary fashion. This powerful combination sensors and actuators acts can be used to solve everyday problem by simply elevating the data that sensor provide to actionable insight that can be acted on by work producing actuators. We can build on the precision agriculture example for the previous section to demonstrate how actuators can complement and enhance a sensor so only solution. For example, the smart sensor used to evaluate soil quality by measuring a variety of soil, temperature, and plant characteristics can be connected with electrically or pneumatically controlled valve actuators that control the water, pesticides, fertilizers, herbicides, and so on, intelligently triggering a high precision actuators which are based on well defined sensors, readings of temperature, pH, soil or air humidity, nutrient level, and so on to deliver a highly optimized and custom environment specific solution is truly smart farming. Okay. So together actuators and the sensors, right? We can achieve lot of things when it comes to the IoT related networks. Okay. Another kind of devices, okay, they are called as the another kind of devices they are called as the micro electromechanical systems, that is MEMS. One of the most interesting advances in sensor and actuator technology is how they are packaged and deployed. Micro electromechanical systems, sometimes simply referred to as micro machines, can integrate and combine electric and mechanical elements such as sensor and actuators on a very well millimeter or less scale. One of the keys to this technology is a microfabrication technique that is similar to what is used for microelectric integrated circuits. This approach, which allows mass production at very low cost, the combination of tiny size, low cost, and ability to mass produce makes the microelectromechanical systems an attractive option for a huge number of IoT applications. Okay. If you take, for example, MEMS devices have already been widely used in variety of different applications and can be found in very similar everyday devices. For example, inkjet printers use micropump MEMS, smartphones also use MEMS technologies like accelerometers and gyroscopes. Okay. In fact, automobiles were among the first to commercially introduce MEMS into the mass market with the airbag accelerators. See the diagram? Okay. This is a torsional ratching accutator. It is taken from the Sandia National Laboratory of the some summit. Okay. Then the technologies. So this is a low voltage alternative to micro engine we can use. Okay. This figure is only a few hundred micrometers across. Scanning electron microscope is needed to show the level of detail visible in the figure. Micro-scale sensors and actuators are immensely embedded in the everyday objects, which is a defining characteristics of IoT. For this reason, it is expected that IoT will trigger a significant advances in MEMS technology and manufacturing and will make them pervasive across all industries and vehicles as they become broadly commercialized. Okay. So this is about the smart objects. Okay. And their characters. Micro-scale sensors and actuators are immensely embedded in everyday objects, which is a defining characteristics of our Internet of Things tech network. Okay, this is about the actuators. Okay, so next we will learn the smart objects.